Delegated transactions allow an account to give external keybooks the authority to sign transactions within a key page of its keybook. These external keybooks can belong to the same ADI, which makes them local delegates, or to a different ADI, which makes them remote delegates. We introduced keybook authorities and delegates in a previous video linked below, so make sure you watch that before you continue on. The best way to illustrate delegated transactions is to consider shared authority by two ADIs. We'll call one ADI Alice and the other ADI Bob. While their URL-based addresses are technically ACC://Alice and Bob, we'll drop the prefix to make things easier. So every ADI has at least one keybook, and every keybook has at least one key page. You can name a keybook anything, but a key page can only be a number that refers to its priority level. However, Alice and Bob aren't really creative, so we're going to assume that each ADI gave their keybooks the generic name book, and each book only has a top-level priority key page 1. So we have Alice/book/1 and Bob/book/1 as our key page URLs for both ADIs. And finally, we know from the second video linked below on key management that every key page has at least one entry, which could be a key hash, a keybook URL, or both. Alice's key page has 5 entries, we'll say, meaning it contains 5 total slots that can hold 5 total keys and/or keybook URLs. Her key page requires a signature threshold of m=2, meaning that 2 signatures out of 5 are required to execute a transaction. We're also going to assume that slot 3 will specify XYZ as the key and the keybook URL Bob/book as the owner of that key. In this case, Bob/book is considered a remote authority because Bob is a different ADI that has signing authority within Alice's key page. Because Bob/book is the owner of slot 3 and Alice/book/1, Bob can use any key from any key page in Bob's keybook, just like it was key XYZ in Alice's own key page. Bob can use his keys in Bob/book to sign transactions executed against Alice/book. However, because m=2, Bob cannot modify Alice/book or anything else it governs without acquiring a second signature. However, Bob can modify slot 3 of Alice/book/1 using either key XYZ or Bob/book. Bob/book is also able to replace key XYZ with some other key ABC, but key XYZ cannot modify the owner of slot 3. In other words, Bob/book does not have the authority to replace itself with another keybook. That makes transactions safer for Alice because if Bob had some legal authority in the real world, for example, if Bob was an accredited investor, then you wouldn't want some other keybook lacking that legal authority to be able to sign transactions. So up until this point, we've only been describing a remote authority, not a delegate or a delegated transaction. To make it into a delegated transaction, Bob's key page, which is Bob/book/1, would need to specify another keybook as a signer for its transactions. This keybook could be Bob/book2 or say Charlie/book. In a former case, we have a local delegate because ADI Bob is also the owner of book 2. In a later case, we have a remote delegate because a different ADI Charlie owns that keybook. If Bob/book2 or Charlie/book signs a transaction, we call that a delegated transaction. Now the reason we went through all the trouble earlier in defining who owns key XYZ, how key XYZ can be replaced by key ABC, and how multi-sig transactions work between a root identity and a remote authority is because all of these operations we just learned also apply to the next level up when we're talking about delegates. If you really wanted to, you could assign delegates to infinity, where Bob/book2 delegates to Bob/book3, Bob/book4, and so on, or where Charlie/book delegates to Debbie/book, and so on. While there may not be many applications where you need to have more than one delegate, Accumulate gives you the flexibility to define arbitrarily complex authority structures.